For those of you that are already here, you might have some questions. Anything that you want to clarify, discuss with regards to the material so far, with regards to the course? Kamusta na ba? How are you finding it so far? Can I have some feedback? How do you find the course so far to the people that are already here? Wala? So I have feedback from David and Patrick. Medyo mahirap. Medyo mahirap. Ano yung mahirap? Para malaman ko, no? Ano yung mahirap, David? Ano yung mahirap? Maybe ano, no? David or Patrick, you can tell me. Anong mahirap? Mahirap ba talaga o kailangan ng practice? Okay. So there's a question from, I don't know, tama ba pronunciation ko? Neruberg? Di ba mag-extend ang deadline ng quiz 1? Watch out for an announcement, ano? Kasi pinag-uusapan namin yan kung mag-extend ang deadline o hindi. I think baka, no? Baka. Hindi lang ako sigurado. Okay, but watch out for an announcement. Okay. So, may nalilito sa equivalent resistance. Kapag hindi ka sanay sa equivalent resistance, medyo nakakalito talaga, no? Because, well, yung trick dyan is really just trying to identify what is connected to what are connected in between nodes. Basically, that's the trick. So you try to redraw the circuit and then redrawing all of the resistances and identifying what is connected between nodes. So it really takes some imagination, I guess. Again, practice. Anything else? By the way, nakita na nyo siguro yung announcement sa UVLE that there's going to be a quiz 2 that will be released. Quiz 2 will be, actually it's already in UVLE. It's going to become active tomorrow at 12 noon. Okay. Quiz 2 will cover week 2. And then also your problem set for week 2 has also been released. I just made the announcement that the deadline for the problem set, for the week 2 problem set, is extended to Monday. So it's no longer Friday, it's extended to Monday. Yung quiz 2, the quiz will be closed on Saturday. And then within this week, maybe toward the end of the week, i-release na rin yung quiz 3. Quiz 3 is supposed to cover this week and also problem set 3. So unti-unti hahabol tayo, no? Yun ang objective namin. Kasi na-delay tayo dahil sa unavailability of UVLE. So little by little, we're going to try to catch up so that hopefully by the Holy Week break, nakahabol na tayo. We will have a more regular schedule of when quizzes will be released and when problem sets will be released. The point is, we don't want this to accumulate. Yun yung nangyayari ngayon, nag-accumulate, no? Sana within any particular week, you're only working on one quiz and one problem set. Okay? That's why kailangan humabol. Okay. So again, no, here I give it a few more minutes, maybe about 3 or 4 more minutes. If there are questions that you want to think about, think about them now and ask them now. Otherwise, I'm going to start the lecture for today. So I'll give you guys a few minutes. Last chance for questions before I start the lecture. So again, no, on anything, no, about the course, about the previous material, any concepts that you want clarified. The only thing I cannot answer are the solutions to the problem sets or quizzes. But anything else, I'm willing to answer. Okay, let's start the lecture for today. No? So today we're going to take up nodal analysis. This is the week 3 material. So this is a summary of what I'm going to discuss for today. First, I'm going to take up a general procedure with you. So the general procedure can probably solve maybe 80% of all cases, but then there are certain complications. Certain circuits have certain complications. So we're going to add those complications little by little. The first complication is, what if you have a floating voltage source The second complication is what if you have dependent sources? And then finally, what if you have floating dependent sources? This is a review of what I already introduced last time. What is nodal analysis? It's a systematic method of analyzing circuits which reduces the number of simultaneous equations needed to solve for all required circuit quantities. Now, if you recall, last week, if you have n essential branches, what did we say? Then usually there will be n branch currents. Then there will be n branch currents. Okay. This will be your number of unknowns. Okay, sometimes nababawasan yan, pag minsan nababawasan yan dahil in certain branches, alam na natin kung ano yung current. But in general, okay, if you do not know the current in any of the essential branches, you're going to need n simultaneous equations to solve for the n unknowns. And you can see that there are many, many essential branches in a typical circuit. In the circuit that we use as an example, there were 7 essential branches, although we knew the current in one of the essential branches. So we needed 6 simultaneous equations. Okay, what's nice with nodal analysis, the nice thing about nodal analysis is that typically the number of simultaneous equations needed would be equal to the number of essential nodes minus 1. That is typical. No? The number of simultaneous equations needed would be equal to the number of essential nodes minus 1. Now, the method is based on the fact that if you know all the node voltages in a circuit, you can solve for any branch voltage. Let me illustrate that. So let's say I have 4 nodes, 1, 2, 3, 4. Okay. So let's say I have a resistor, 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 resistor. And this is just part of a circuit. And somewhere in the circuit, I have a reference that's connected somewhere in the circuit. Okay, I have, let's say this is node A, VA, VB, VC, and VD. So VA, VB, VC, and VD are the voltages at nodes A, B, C, and D with respect to ground. So this is my ground. If I know VA, VB, VC, VD, it's very easy for me to get my branch voltages. My branch voltages. For example, VAB. VAB is the branch voltage across this particular branch. This is just simply equal to VA minus VB. No? Or VDC. VDC is the voltage across this branch. This is just equal to VD minus VC. Right? So if I know all the node voltages in a circuit, so yung sinasabi ko rito, if you know all the node voltages in a circuit, you can solve for any branch voltage. Okay? And if the branch is a resistor, you can express the branch current in terms of the node voltages. Okay. So for example, okay, what is this current? No? Let's say this is R1. What is I1? I1 is simply equal to VB minus VA over R1. I can express my branch currents in terms of my node voltages and my resistance. What is this current? What is this current? I2. Anyone? Can I hear? Can I hear someone tell me what I2 is? Or are you all asleep? Okay, that's right, no? So from Patrick sabi ni Patrick, I2 is VC minus VA over, sorry, I forgot to put R2, no? So I2 is VC minus VA over R2. Okay? And so forth, no? So if a branch is a resistor, you can express the branch current in terms of the node voltages. Now, why is this important? This is important because in nodal analysis, we are going to be applying KCL. No? So you have to know the currents in the branches for you to apply KCL. Okay, kaya importante ito. Okay, what is the general procedure? General procedure. First, we label all essential nodes in the circuit, number one. Number two, if a reference node has not been designated, select a reference node, which we will also call the ground. Any essential node can be selected. Number three, assign a node voltage variable to each of the remaining essential nodes. This is the voltage at that node with respect to the reference node. So, for example, if we start out with 5 essential nodes, then one is going to be our reference. So for the remaining 4 essential nodes, we have to assign a node voltage variable. This is the voltage at that particular node with respect to the reference nodes. And then number 4, identify the node voltages which can be determined by inspection. Okay, you're going to see that in the examples later on. For the remaining essential nodes, these are the nodes whose node voltages you cannot determine by inspection. You write the appropriate KCL equation. So ito yung sinasabi ko kanina. In the nodal analysis method, we are going to be writing KCL equations. But we are going to express currents in terms of node voltages. Then we solve the system of equations, and then we solve for the required quantities from the node voltages. That is going to be clearer through an example. So find the voltage Vx using nodal analysis. Okay, I want this to be a bit interactive. How many essential nodes are there in the circuit? How many essential nodes? Yung mga hindi sumasagot, can you try to answer, please? Because there are only a few, there are probably only 3 or 4 people that try to answer. Okay, I'm getting a variety of answers. 4, 2, 4, 4, 5. Okay, 3. Okay, there are 4. No, There are four essential nodes in the circuit. Let's see where they are. This is one. Huh? This is the other. This is the other. And then this whole thing underneath is just one. Okay. So for those that answered two, I think you should try to go back to the definition of an essential node. No? Essential node is a point of interconnection between three or more elements. So it has to be between three or more elements. No? The ones that said five, you might have mistaken this to be more than one node. This is only one node. So there are four essential nodes. So ang gagawin natin, we're going to assign one to be the reference. Okay. We're going to assign one to be the reference. So let's assign this to be the reference. Let's call this G. Okay, and then I will label my three other nodes. So let me label this A, B, and C. And my variables, my unknowns, are going to be VA, VB, and VC. VA, VB, VC. So I have three unknowns. How many equations do I need? Three unknowns. How many equations do I need? Obviously, three. I need three equations. However, do I really have three unknowns? Talaga bang tatlo ang unknown ko? Take a look at the circuit. Doon sa procedure kanina, sinabi ko, after assigning your variables, look at the circuit and try to figure out whether there is a variable that you can determine by inspection. Is there a variable here that I can determine the value of by inspection? Anyone? That's correct, no? So sumagot si Patrick, the value of VA is obvious. Okay, so did Mark answer? The value of VA is obvious. VA is equal to 4.8 volts. Okay, why? Your voltage source is between node A and node G. No? That means VA minus VG should be equal to 4.8 volts. But VG is our reference, no? When we make a node the reference, we're putting it at zero potential. No? In other words, VA minus VG is just equal to VA. No? So VA is equal to 4.8 volts. So actually, we only now have two unknowns. No? Two unknowns remaining. No? So for the nodes associated with these, we apply KCL. No? So our unknowns are VB and VC. So we apply KCL to nodes B and C. Okay, again, no? Alam na natin kasi kung ano yung VA eh. So ang mag-KCL na lang tayo dito sa B at saka dito sa C. Okay, let's try to do the KCL, no? So let's try KCL at B. Okay, here is my suggestion, no? If you do not know the direction of current in a branch, you always assume it is flowing out of the node. So this is a suggestion. If current direction is unknown, assume flowing away from the node. If the current direction is unknown, you assume it is flowing away from the node. No? So if I apply KCL to B, how many currents do I have? This is one current. Let me call this I1. This is another current. Let me call this I2. And this is another current. Let me call this I3. So notice, I assume that they are flowing away from node B. So what is KCL at B? KCL at B is I1 plus I2 plus I3 is equal to 0. No? Remember yung usual convention, if it is flowing away from the node, we assume it is positive. But what is I1? I1 is VB minus VA over 30. What is I2? I2 is VB all over 15. And finally, I3 is VB minus VC all over 10. So this is equal to 0. So I1, no? I1 is VB minus VA divided by 30. I2 is VB minus 0, no? Because VG is equal to 0, divided by 15. So that's just VB over 15. And I3 is VB minus VC divided by 10. Okay? So you add all of those three currents, you should get 0. That is KCL at B. Okay, after we do KCL at B, pwede natin kalimutan yung mga directions ng currents. Okay, let me now do KCL at C. KCL at C. So I'm now at C. I can now assume this direction of currents, no? So let's assume this direction. Well, this direction of currents. Ito, alam na natin yung direction nito, so we don't make any assumption. So let's do this one by one. No? So KCL at C. What is this current? Ano itong current sa taas? Someone? Anyone? If you don't want to type it out, you can say so. No, just shout it out. Okay, mahiya. So what is this current? Anyone?
Ano po, sir? VC minus VA over 40.
Okay, very good. No, VC minus VA over 40. What about this? Ano ito?
VC minus VB over 10.
VC minus VB over 10, no? And then you have, okay, ito naman pababa, that's just VC over 20. May kulang pa, no? Ito. What is this? Is this plus or minus? Is that plus or minus? Negative, no? Negative, because it is entering the node. So minus 0.2, and this is equal to 0. Okay? There's a question here. Pag sorry, no? Pag nagkabaliktad ba yung sa subtraction part, magkakamali po yung sagot. Of course, no? You have to have the correct sign all the time, no? I'm not sure I understood your question, no? But yeah, you have to be mindful of your signs, no? The direction of current will dictate the sign. That's why I said, if you don't know the direction of current, maganda to just assume that it is going away from the node, because if it's going away from the node, then your terms are positive. No, this is positive, and this is positive. Okay. Anyway, I have two equations. But remember, I only have two unknowns, no? Because alam ko na itong VA. This VA is 4.8 volts, no? So this is 4.8, no? This is equal to 4.8. So in effect, I have two equations and only two unknowns. Okay? So that means that I can now solve for VB and VC. So anyway, so these are the two equations that we already formed. No? This is for node B, for node C. Okay. So solving for VB and VC, and how will you do this? Ito hindi na iito. If you put your equations in standard form, then you can use your calculator. Okay. Gamitin na lang niya yung calculator. And so you come up with VB is equal to 2.4 volts and VC is equal to 3.2 volts. Okay, what was our problem? The original problem was, what is Vx? Well, it's easy to determine Vx. Vx is just VA minus VB. So that's 2.4 volts. There's a question. Yeah, would it be fine kung yung convention for sign is baliktad? Current away is negative, current to is positive? Yes. No, it's just a convention, no? Just a convention. By convention, yung current moving away usually is positive, current entering is negative, but as long as you're consistent, if you want to use the opposite convention, you can. There's no problem. Okay? Any other question?
Sir, sa VX po ba kaya naging positive yung VA kasi nasa positive side siya ng polarity?
Yes, exactly. No? Susundan mo yung assumed polarity ng Vx. That's why, pag yun yung assumed polarity ng Vx, you're assuming that the left side is of higher potential than the right side, no? And therefore, the potential difference would be VA minus VB. Okay. Now I'm going to point out something, no? Dito, sa current dito sa 30 ohms, what was the assumed direction of current in this particular term? Is it left to right or is it right to left? No?
Right to left po.
It is dito, it is right to left, no? Okay. No. Sorry, no? Ito na lang, sorry. Let's use this example. Ito, no? The current here is given by this expression, no? So what is the direction? What is the assumed direction of current here? No? Given by this expression. Is it right to left or left to right? It's left to right. No? Left to right. Okay. The current here, given by this expression, is what direction? Is it right to left or left to right? Anyone? Dito. This time it is right to left. So meaning to say, our assumed direction of the current in the 10 ohms here and the assumed direction of the current in the 10 ohms here is different. That is okay. Walang problema yon. In other words, when you form your KCL equation for one node, you can assume a certain direction of current. When you go to the next node, you can assume the opposite direction of current because that is taken care of by the node voltages. What if dito? What if here I assumed, because here I assumed it is right to left, no? What if here I assumed it is left to right? Ano mangyayari sa term na to? If I assume that this is left to right, what will happen to my term? No? So if it is left to right like this, okay, this is going to be VB minus VC over 10, but instead of being positive, it's going to be negative. Was there a difference? If you take a look at these two, it's exactly the same. No, because minus VB minus VC over 10 is the same as plus VC minus VB over 10. So it doesn't matter whether you assumed it is right to left or left to right. You're going to get exactly the same expression. Just be careful of the sign of your current. If it is moving away from the node, it should be positive. If it is moving toward the node, it should be negative. Are there any questions? Any questions? Okay, so we only had to solve for two equations in two unknowns. Isn't that nice? If you had not known the node voltage method and you'd solved this using the techniques that we learned last week, how many equations would you be solving? You'd probably be solving for 4 or 5 equations in 5 unknowns if you wanted to know all the branch currents. You'd have to solve for many more equations in many more unknowns. So that's the beauty of the node voltage method. Okay, let's now add a complication. What is this complication? The case of having a floating voltage source. Now, this is a floating voltage source. Okay, how many? Okay, we have 3 unknowns, no? We have 4 essential nodes, A, B, C, and our ground, 4 essential nodes. So we have 3 unknowns. The unknowns are VA, VB, and VC. These are the node voltages at the essential nodes, excluding the ground. So we need 3 equations. Nakalagay dito, we need 3 equations. So dun sa node A, madali, no? KCL sa A, at A. Okay. What is my expression for this current? For the current in the 8 ohms? Anyone? Just shout it out. Anyone can shout it out. Okay, VA minus VC over 8. No? Okay, what is my expression for this 6 ohms? The current in the 6 ohms. Anyone? Shout it out. Okay, VA minus VB over 6, no? Plus, because they're both moving away from the node. Meron pa, no? Itong term na to, no? Ano ito? Is this plus 3 amperes or minus 3 amperes? Is that plus or minus?
Minus po.
Negative, no? Tama, negative. So minus 3 equal to 0. So one equation down. Okay. Let's try KCL at B. Subukan lang natin. Okay, what's my expression for this current here? What's the expression for that current there? Okay, that's VB minus VA over 6. Okay, what's my expression for this current here going down? That's going to be VB over 3. Tapos na ba? Tapos na ba? Is that the end? Yes or no? Any brave soul? Any brave soul that will answer? Are those my only two terms? No, no. From Peter, sabi no. Bakit Peter? Bakit no? Why no? Don't be shy, no? You can speak up. Bakit no? Because that's correct, no? That's correct. Because the voltage source has a current that passes through it. Remember that there's a current that flows this way from the voltage source, no? It's called this I6V. So you have another term here, no? This is minus I6V is equal to 0. But what happened here? Ano nangyari rito? This is a new unknown. That's a new unknown. Kanina, tatlo lang yung unknown natin, no? We only had 3 unknowns. Now, we now have 4 unknowns. And therefore, we would need an additional equation. We don't want to go this path. Kasi babalik na naman tayo sa masyadong madaming simultaneous equations ang sinosolve natin. So we don't want to go this path. No? Remember, our point here is trying to simplify the solution to the problem. No? So we already formed the KCL equation for A. I already mentioned this. We cannot apply KCL to either node B nor node C without introducing a new unknown variable, which is the current flowing through your 6-volt source. Instead, what are we going to do? Instead, we are going to combine node B and node C into what we call a supernode. Into what we call a supernode. So this is our supernode. Okay, ano yung katangian nitong supernode na to? Let me say this is my supernode, no? I actually don't have to know what is inside my supernode. So I have currents. No? I have currents that are flowing into and out of my supernode. Let's call this, let me just call this I1, I2, I3, I4, and I5. This supernode, itong supernode na to, cannot accumulate charge. Thus, KCL should be applicable. In other words, the currents entering should be equal to the currents leaving, or I1 plus I2 plus I3 plus I4 minus I5 should be equal to 0. Because this cannot accumulate charge. Kahit anong nasa loob niyan, ano, it doesn't matter what's inside here. I don't even have to know what's inside there. All I know is the currents entering must equal to the currents leaving. Otherwise, charge will be accumulating in it. So that is the characteristic of a supernode. So, having said that, what is the KCL equation for this supernode? What is the current here? The current here from B to A is VB minus VA over 6. The current here going down is VB over 3. The current here from B to A is VC minus VA over 8. And the current here going down will be VC over 4 May kulang pa. Ito naman, papasok, minus 5 is equal to 0. So, I have two equations now. Yung isang equation ko, yung equation para rito. Yung isang equation ko, yung equation para dito sa supernode. Kulang pa ako ng isang equation. Saan manggagaling yung third equation ko? Okay. If you take a look at your two equations, all the information in the circuit has already been used except for one thing. Ano yung hindi pa lumalabas in any of your two equations, in the two equations that we have? Ano pa yung hindi pa lumalabas? Or ano pa yung hindi pa nagagamit? Sino yeah, I heard that, no? Ang hindi pa nakagamit is yung voltage source. Hindi pa nag-appear anywhere yung 6 volts. Now, what is the effect of the 6 volts? We connected a 6 volt source between node B and node C. No? We connected a 6 volt source between node B and node C. What does that do? That forces the potential difference between B and C to be 6 volts. In other words, VB minus VC must be equal to 6. Yun ang ginagawa ng 6 volt source. So this is now my third equation. Okay. So if I go back here, this is equation 1. No. Then this is equation 2. This is equation 3. 3 equations, 3 unknowns. Put it in standard form. Enter it into your calculator, and you should get your solution. So this is what we wrote down. So what is that? Solving simultaneously, you're going to get VA is 24, VB is 16.3, and VC is equal to 10.3. The 6 volt source is called a floating voltage source. The reason why it's called that, is because neither of its terminals is connected to the reference node. So if this were connected to the reference node or this were connected to the reference node, it's not considered a floating voltage source. But neither of its terminals are connected to the reference node, so it's called a floating voltage source. And when you have a floating voltage source, then the easiest way to solve the problem is by combining the nodes that that voltage source is connected to into a supernode. Any question with regard to this example? Any question? Okay. Let's take another example. So, itong node voltage method, we're going to be illustrating this by means of an example. So use nodal analysis to solve for the power dissipated by the 2K resistor. So I want to solve for the power dissipated by the 2K resistor. So again, my first question, how many essential nodes are there? How many essential nodes are there? 2, that's right. No? Bakit may question mark? Di ka sigurado, Patrick? No? You should be more deliberate in your answer. No? 2, okay? No, sorry, no, I didn't mean to embarrass you, no. But there are 2 essential nodes, this node and this node. No? So let me call this node A, and let me make this my ground. No? So in effect, my variable will be VA. No? This is going to be my unknown. And what I want to do is apply KCL at A. Okay. Ang problema, let me try to apply KCL at A. No? I will have 3 currents associated with node A. No? Okay. Let me call this I 8V, and let me call this I 2V. What is my KCL at A? I'll have I 8V, okay, that's the current flowing away from node A here, and then plus VA over 2K, okay, plus I2V is equal to 0. So pag tinignan mo to, sa unang tingin mo, ang makikita mo, one equation, pero 3 unknowns. This is unknown, and this is also unknown. Okay, ito yung tanong ko. Unknown ba talaga itong I8V? Or can we express this in terms of V's of A? No? Can we express I8V in terms of V's of A? Take note that the value of the voltage at this particular node, no, is equal to 8 volts. Because this voltage source constrains the voltage between this node and ground. No? In other words, this node voltage must be equal to 8 volts. And therefore, itong I8V is really just VA minus 8 over 1K. Okay? I8V is VA minus 8 over 1K. So we can express I8V in terms of my unknown, no? In terms of VA. Can I do the same for I2V? Can I do the same for I2V? Can somebody give me an expression for I2V in terms of VA? Anyone?
Sir, hindi po ba gagawing supernode yung sa 2V?
Pwede. I'm going to discuss that later, no? I'm going to discuss that later. Pwede. But for the meantime, no? Can you find an expression for I2V in terms of VA?
VA minus 2 divided by 3. Hindi ako sure.
Nice try, nice try. Nice try, no? So ang sagot VA minus 2 divided by 3. Okay. Ano mas mataas ang potential, dito or dito?
Ay, oo nga. Ay, sorry.
Right? Ang mas mataas yung potential dito, no? This has higher potential than this, no? Kasi itong 2 volt source, you're going from a lower potential on the left to a higher potential on the right. Now, what is the voltage at this node? The voltage at that node, the voltage at this node is just VA plus 2. Okay? Another way of looking at it, no? Kung masyadong mabilis para sa inyo, let me say the voltage here is, sabihin natin Vx, no? Let's say that's Vx. So Vx minus A is equal to 2, and therefore Vx is equal to 2 plus, minus VA is equal to 2. So Vx is equal to 2 plus VA. No? Let's say this is Vx, this is VA. So Vx minus VA is equal to 2 volts, and therefore Vx is equal to 2 plus VA. So the voltage at this node is VA plus 2. I'll just erase this kasi nakakalito. So now what is this current? This is also I2V, which is VA plus 2 all over 3K. Right? So I2V is VA plus 2 all over 3K. So actually, pag ito, pinasok ko dito, pag ito, pinasok ko dyan, I'm only left with one unknown, VA. So the key here is, okay, you apply only one KCL equation, but you have to be able to recognize what this current is and what this current is. So anyway, that's in the note, no? So, yeah, no? So there are only two essential nodes. Okay, I1, ang ginamit ko pala is I1K and I2V, no? So, yun, I1K, and then you have I2V, and then finally, this is my final equation. Any question? Okay, so there was an earlier question. Pwede bang gamitan to ng floating voltage source? Actually, you can. You can. Okay. So in this particular case, kahit na hindi siya essential node, we are going to assign a voltage variable. So let's say this is A and this is B. No? So we assign a voltage variable even if B is not an essential node. So pwedeng gawin yun, no? There's nothing wrong with doing that. Because you can actually add voltage variables to your non-essential nodes. It's just that dumadami yung unknowns mo. Dumadami yung unknowns mo. We want to prevent increasing the number of unknowns. But in this particular case, if that is what will expedite the solution to the problem, you can do that. And so now this turns out to be, this thing now turns out to be a supernode. And then I can form my KCL for my supernode. KCL for my supernode. Okay, what is this term? Remember that this is 8 volts, no? That's 8 volts there. So what is this current term? This current term is VA minus 8 over 1K. Itong pababa, that's VA over 2K. Ito naman bumababa dito is VB over 3K. Sorry, no? This is equal to 0. Remember, this is my ground. Two unknowns. However, we know that VB minus VA is equal to 2. So I have two equations. So I can solve for VA and VB. So that answers the question. Can you treat it as a supernode? Yes, you can. So again, this illustrates the fact that there are many ways to solve a particular problem. But basically, what we're doing here is still nodal analysis. Any question? So there's a question here. Paano nalaman na VB minus VA at hindi VA minus VB? Okay. Kasi the 2-volt source, the positive terminal is on the right, no? The negative terminal is on the left. Therefore, the right side has a higher potential than the left side. Okay? And therefore, it's VB minus VA. Okay? Tapos, bakit hindi 8 minus VA? Dito naman. Kasi kung 8 minus VA, so there's another question, bakit itong term, no? Bakit VA minus 8, hindi 8 minus VA? Kung 8 minus VA, ano magiging term ko, no? Ang current ko magiging papasok. So it's going to be 8 minus VA over 1K, pero papasok siya, and therefore magiging negative. Okay, compare this and this. These are the same. Okay, pareho siya. That's why I was saying, no, hindi nakakalito. You just keep assuming, always assume that the current is flowing away. Because if the current is flowing away, then itong node na to minus this particular node, no? This node minus this node to ground. Always flowing away, laging positive. Any other questions? Okay, we'll take one more example. Sorry. That's the notes, no? Okay, in this example, ang magiging complication natin is, okay, there is a dependent source. This is a voltage source that is dependent on the current, so it's a voltage dependent, a current dependent voltage source. No? That's what you call it, a current dependent voltage source, or a current controlled voltage source. So ang voltage na linalabas nito depends on this particular current. Okay, what are our sorry. What are we supposed to do first? Let's assign a reference node. So sabihin natin ito yung reference node ko. No? This is my entire reference node. And then I assign my variables. So let's call this node 1, node 2. So my variables will be V1 and V2. So I have two equations. Two unknowns, V1 and V2. So I have to form KCL at nodes 1 and 2. No? Kung saan nandun yung unknown mo, okay, doon ka magpo-form ng KCL. Okay, now take note. What is the voltage at this node? The voltage at this node is constrained by the 20-volt source. So the voltage at this node is 20 volts. And then what is the voltage at this node? Okay. The voltage at this node is 8 I's of phi, because it is constrained by this controlled voltage source. Okay, so gawin ko ngayon yung KCL ko sa 1. KCL at 1. Okay, what is this? That's V1 minus 20 divided by 2. What is this? Okay, that is plus V1 over 20 And then what is this? That's plus V1 minus V2 over 5. That's equal to 0. Okay. And then let's do KCL at 2. KCL ako rito. Okay, what is this? From right to left. That's V2 minus V1 over 5. Itong pababa is V2 over 10. Ito naman, pakanan dito, this way, plus V2 minus 8 I phi over 2 is equal to 0. Okay, ano yung problema natin? What is our problem? I have my two equations.
Yung I po.
That's right, no? So may sumagot si Patrick. I have a new unknown. Ano yung unknown ko? Ito. This is also an unknown. But is that really a problem? Actually, hindi naman talaga siya problema because I can express I phi in terms of my node voltages. What is my expression for I phi? Can I hear someone? Ano expression ko for I phi?
Minus V2 over 5 po.
Exactly, tama, no? V1 minus V2 over 5. So this is my third equation. So this is equation 1, this is equation 2, this is equation 3. So, calculator na lang ang problema. Okay. Okay. Now, what is the power dissipated in the 5 ohm resistor? Okay. Anyway, I can already plug the notes. Ano? So this is exactly what we did. And then this is my third equation. No? V1 minus V2 over 5. Doing my calculator magic, makukuha ko is V1 is 16 and V2 is equal to 10. Okay. And therefore, I phi, which is V1 minus V2 over 5, I'm going to get 1.2. And what is this? This is just I squared. No? So this is P5 is equal to I phi squared times 5. No? I squared R. So this will give you 7.2 watts. Any questions? Okay, I'm going to stop here, no? I still have this example. So ito we'll make it a little bit more complicated now. This time my control source is a floating source. So how do I solve now for the voltages VA, VB, and DC when I have this floating source? Actually, dapat kaya na yung gawin yan, ano? So you can try it as an exercise, but we'll discuss it in next week's lecture. I want you to absorb first the first three cases that we took up earlier today. Try to absorb it, then try to do this on your own, no? And then I also have some, so may solution na rito. I also have some exercises that I want you to try out, no? There are three exercises, and we're going to discuss this all next meeting. No? So, are there any questions on anything, no, not necessarily on this course alone, but on this lecture alone, but on anything so far. Any questions? Any questions? Any difficulties you're experiencing with the problem sets? They're supposed to be double your number in the class, ano? Ano nangyari sa iba? Tinatamad, tinatamad mag-attend ng online lecture, nahihirapan mag-log in. Well, I hope it's not because they have poor internet connection. No? But anyway, if there are no questions, that's it for teka, may mga tanong yata, no? I mentioned this earlier, no? Baka late yung nag-attend, no, si Mark. There's a quiz that will be released tomorrow, or that will be opened up tomorrow. So may quiz. It will be due on Saturday. No, this is for week 2. And then for week 3, toward the end of the week, there's going to be a quiz that will also be released. No? And there will also be a problem set that will be released for week 3. Ang problema namin ngayon is naghahabol, ano? Kasi nagkaroon ng malaking delay dahil sa problema sa Uble. Hopefully hindi na magkaroon ng problema sa Uble. But there was a delay, parang na-push out lahat. So little by little we'll try to catch up so that maging regular yung schedule. No, we don't want it to happen that on any given week you're working on 2 problem sets or you're working on 2 quizzes. Pero hindi natin maiiwasan yan right now that you're going to be working on 2 quizzes. Maybe until next week you'll be working on 2 quizzes and 2 problem sets simultaneously. But after that, hopefully hindi na. There's a question. Basta, okay, so somebody said na dahil nag-compress, bumaba yung quality. Basta naman siguro nababasa eh. I'm not going to be the one to correct, no? We have graduate assistants that are going to do the corrections. Important thing is it should be readable, no? So yung guide dyan is if you pretend to be the graduate assistant and you're having difficulty reading it, then wag na nyo pahirapan yung graduate assistant. Siguro lakihan na ninyo yung mga sulat nyo or linawin nyo yung mga sulat nyo, no? Because it's difficult to check something if the person trying to check cannot even understand your handwriting. So diskarte na lang siguro. You try to gauge on your own whether it's readable or not readable. Any other questions? So far, so good. Lagi kong sinasabi to sa mga klase ko, no? When people don't ask questions, that's one of 2 things. One is, naintindihan nyo yung pinag-usapan natin today, which I hope is the case. The other is, wala kayong naintindihan. So, I'm just hoping na meron naman kayo sana naintindihan, ano? Okay? So, I guess that's the end of today's session. So, thank you very much. I'll see you again on Thursday. Okay.
Thank you po, sir.
You're welcome. You're welcome.